What is biomass? Biomass is an organic material that comes from plants and animals, and it is a renewable source of energy. It is a sustainable power source not just because the energy in it originates from the sun, yet additionally on the grounds that biomass can redevelop over a moderately brief time frame, unlike the hundreds of years that it took for fossil fuels to form. It can be used in a power station to generate electricity. Biomass can also be purposely grown energy crops, wood, or forest residues, waste from food crops, horticulture, food processing, animal farming, or human waste from sewage plants. Types of biomass: wood and agricultural biomass, solid waste, landfill gas, and alcohol fuels. The advantages of biomass. Number 1. Biomass is always and widely available. As a renewable source of energy, the organic materials used to produce biomass are infinite, since our society consistently produces waste such as garbage, wood, and manure. Number 2. It is carbon neutral. As a part of photosynthesis, biomass fuels only release the same amount of carbon into the atmosphere as was absorbed by plants in the course of their life cycle. Number 3. It reduces the over-reliance on fossil fuels. Not only is there a limited supply of fossil fuels, but fossil fuels come with environmental baggage, including the release of large amounts of carbon dioxide into the atmosphere and the pollutants that result from removal, transportation, and production. Number 4. It is less expensive than fossil fuels. While fossil fuel production requires a heavy outlay of capital such as oil drills, gas pipelines, and fuel collection, biomass technology is much cheaper. Manufacturers and producers are able to generate higher profits from a lower output. Number 5. Biomass production adds a revenue source for manufacturers. Producers of waste can add value by channeling their garbage to create a more profitable use in the form of biomass energy. Number 6. Less garbage in landfills. By burning solid waste, the amount of garbage dumped in landfills is reduced by 60 to 90% and reduces the cost of landfill disposal and amount of land required for landfill. The disadvantages of biomass. Number 1. Biomass energy is not as efficient as fossil fuels. Some biofuels like ethanol is relatively inefficient as compared to gasoline. In fact, it has to be fortified with fossil fuels to increase its efficiency. Number 2. It is not entirely clean. While biomass is a carbon neutral, the use of animal and human waste escalates the amount of methane gas, which are also damaging to the environment. Additionally, the pollution created from burning wood and other natural materials can be considered just as bad as that resulting from burning coal and other types of energy resources. Number 3. It can lead to deforestation. Since wood is one of the most used sources of biomass energy, vast amounts of wood and other waste products have to be burned to produce the desired amount of power. While currently there is enough wood waste already, there is a risk of deforestation. Number 4. In some cases, it can be a major cause of pollution. Despite the frequent depiction of biomass as clean energy, data from air permit applications and real smokestack tests demonstrate quite clearly that biomass is a heavily polluting technology. Burning wood and other biological materials for energy emits as much or more pollution than burning fossil fuels, including coal. Emissions is a function of the fuel type, combustion temperature, and the pollution controls, but in PFPI's analysis of air pollution permits in 7 states, we have found that biomass burners are always more polluting than natural gas and are similar to coal, admittedly better for some pollutants like sulfur and mercury, but the same or worse for particulates and nitrogen oxides.
Operational challenges: feedstock unavailability. Inefficient resource management and the government non-intervention approach are the key factor hindering the expansion of biomass industry. Regional and seasonal availability of biomass and storage problem. The seasonal variation results in the fuel price. As the energy density of biomass is low, acquisition of land for harvesting and storage is difficult. Pressure on transport section. Because of biomass moisture, transporting wet biomass from the plantation to the production site becomes energetically unfavorable and costly, with increasing distance. Inefficiency of conversion facility, core technology, and equipment shortage. Technical barriers were resulted from the lack of standards of bioenergy systems and equipment, especially where the energy sources are so diverse. Appropriate pre-treatment required to prevent biodegradation and loss of heating value not only increases the production cost but also in equipment's investment. Immature industry chain. It is virtually impossible to get long-term contracts for consistent feedstock supply at a reasonable price. The low ability to gain profits is also a reason that many upstream firms lack driving forces in the technology reform. Economic challenges. Feedstock acquisition cost. The biomass resources are scattered in order to reduce the cost of transportation. Biomass projects are eager to occupy land close to the source, leading to centralization of biomass projects. Limiting financing channels and high investment and capital cost. Because of decentralized capital, poor profitability, frequent fluctuations of international crude oil prices, and high market risk, seldom investors took an initiative part in the biomass power generation industry. The biomass power generation is subjected to constraints of excessive investment and high operating costs. Biomass pre-treatment technologies have extra costs, which scattered farmers and small-scale fuel companies may not be able to afford. Problems of biomass large-scale supply. One of the biggest problems related to biomass large-scale supply is the energy density. Briefly, if biomass moisture of conventional wood is 30%, this means that every 1 ton of wood transported is 300 kilograms of water. Additionally, biomass feedstock shape, chipped, pelletized, rounded, or baled, strongly influences the bulk density and affect the transportation economics. For this reason, compaction and densification are considered crucial for an efficient biomass supply. The figure below shows the energy density and bulk density of different bio-based feedstock. In addition to the bulk and energy density, large-scale biomass supply is affected by a wide range of bottlenecks, including raw material, initial cost, biomass producers' involvement, environmental regulation, and sustainability. Finding solutions for all these problems means finding the solution for the creation of the future biomass commodity in Europe and worldwide.